Hello and welcome to lesson 2 of week 13. In this lesson, we are going to create a real-world app and we want to design a city fiber network using the minimum spanning tree. Our scenario is for a network company. Let's say you are a network engineer at a company and the company wants to connect 6 office buildings using fiber optic cables, and it wants to do this at the lowest possible cost. So we have this cost of connection between each building based on the distance here. We want to call the 6 buildings office building A, B, C, D, and E. Connection between A and B 4, A and C 2, B and C 5, B and D 10, C to D 3, C to E 4, D to E 11, D to F 8, E to F 6. We want to have these connections, which are the edges, right? And we have the vertices, which are the buildings. So we're going to use this to create a graph, and then we'll use Rushkow's algorithm to generate the minimum spanning tree. Okay, so we'll display all the edges and then we'll display the total cable cost. So let's say the vertices here is equal to, we have the list A, B, C, D, E, F. And now let's say the edges will now be the list of tuples. So let's say we have A, B, and we have the weight here is 4, right? Then we have A, C, and 2. Let me just read this and I will just modify it here. So we have A, C, 2. We have B, C, which is 5. We have B, D, 10. We have C, D, 3. We have C, E. C, E is 4. D, E is 11. We have D, F, and we have that to be 8. Then we have E, F, and we have that to be 6. Okay, so we have all of these edges here, and we want to implement the way we did the Rushkow's algorithm in the last lesson. So let's look at the one we did in the last lesson where we did the Rushkow's. So I'll just copy this and let's modify it according to what we want. So I'll come here and we want to implement the disjoint where we have the vertices. We look for the parents there, we create the find method, and then we create the union method, which is all basically the same, and then we do the Rushkow's algorithm. So now we already have the vertices and the edges here and we want to use that. So let me just cut this from here and let me use that here to test. Then we want to say MST cost will now be equal to Rushkow. In the pair of vertices, we pass in the vertices. So I'm going to paste the vertices and the edges here. It's equal to vertices, edges. And now we want to print minimum spanning tree for edge in minimum spanning tree, print edge. And then here we'll print new line total cost will be cost. Let's run this and we have it correct. So A to C 2, C to D 3, A to B 4, C to E 4, E to F 6, total cost 90. So we have this created. So you can see how we just use the algorithm we created in the last lesson to just get this. So you always get the vertices, which will be like the different cities or the office buildings, and then the edges, so the weight between two edges like that. So this is where we end this lesson. Thank you and see you next week.